Hi students, so in the last class we were seeing about differentiation as well as integration. In today's class we are going to continue the topic from basic maths. So what we are going to learn in today's class, so first of all slope of a graph, then we will learn about maxima and minima. This is most important topic from today's class, and then area of a graph. So these are the concepts that we are going to discuss, and if time is there we will also see the different type of graphs that are available, like a straight line, parabola, hyperbola. So about the graph shapes and the equations which will help in physics, so that we will discuss. Okay, so first of all we will start today's topic with slope of a graph. So we all know a graph is basically a pictorial representation of data. Let us say you are watching a cricket match. So the number of runs scored in a match will be given in y-axis, and the number of overs they will give in a x-axis, correct? And they will try to show you in a graph whether the team 1 is ahead or team 2 is ahead. So like that they will plot. So in physics, how we will use this concept to plot displacement, velocity, acceleration of different bodies, right? So first of all let us learn about a physical quantity called slope. So slope is again two types. First one is average slope, and the second one is instantaneous slope. Average slope and instantaneous slope. So what is happening in average slope? Try to understand, sir. In basic English terms, slope is basically, let us say if you are walking on a plane and the road is horizontal, that means you can say the slope is 0, there is no slope. And if you say the road is little bit inclined like this and you are walking on an inclined surface, you will say the road is high slope, like that, correct? So same story, sir. Slope of a graph, for example, you have two different points. We have taken a certain function, sir, y is equal to f of x. It can be logarithmic, it can be exponential, it can be trigonometry, it can be algebra. Some function is there. That function I want to plot in y-axis as well as x-axis, and somehow the shape ended up like this, let us say. So here we have the first point A, and here we have the second point B. So the coordinate of A is x1 comma y1, and the coordinates of B is x2 comma y2. Two different points. Now we want to find out slope of this particular points. Between these 2 points, what is the slope? So in very simple language, slope is nothing but the amount of inclination, sir. So we will draw a line joining the 2 points, correct? And with the horizontal, how much angle it is taking, let us say theta. So the definition of slope and slope is denoted by letter small m. So and its measurement is tan theta, that is opposite side of the triangle by adjacent side of the triangle. If theta is the inclination with x-axis, then tan theta is called slope of this particular points between point A and point B. So point B is this much above point A, this much slope is there, like that, when you compare these 2 points. So tan theta, sir. So you can focus on a triangle that is forming here. Yes, so you can focus on a triangle here. We have a triangle in such manner. So whose opposite side? From here to here it is y2, here to here it is y1. So the opposite side of the triangle is y2 minus y1. This is y2, this is y1. So opposite side is y2 minus y1. And from here to here it is x1. From the origin to here it is x2. So the adjacent side of the triangle would be called as x2 minus x1. So the measurement, that is slope, which is nothing but tan theta, is becoming y2 minus y1 by x2 minus x1, that is change in y by change in x. What it is becoming, sir? Change in y by change in x. Okay, so that particular measurement, we are naming that particular measurement as the average slope between point A to point B. Is that clear? Right. So I'll try to change the slide, sir, now. Next, instantaneous slope. So average slope was the amount of inclination into tan, like tan theta. That is average slope between two different points. Now instantaneous is basically at a particular point. Let us say I am talking about velocity. I started at Kondapur, which is a place in Hyderabad, to Miapur I am going, and it took me, let us say, 1 hour to travel the 10-kilometer distance. Okay, then the whole journey average speed will be 10 kilometers per hour. Correct? But at a particular instant, I started at my journey at 10 o'clock, ended at 11 o'clock. Right? So now at 10:30 specifically, I may be stopped at a signal, or I may be going with a 20 kilometer per hour, I may be going with 10 kilometer per hour. Yes or no? So at that instant, what is my speed is there? That is instantaneous speed. So similarly, between two different points, when you take, that is average value. At a particular point, if you take the speed, that is instantaneous value. Same here also, slope I am trying to find between two different points means I will call it as average slope. And at a particular point I am going to try means it is called a instantaneous value. Let us say at this point x1 comma y1, we have a point P. Now I want to see the instantaneous slope. So for that, what I will do, I will draw a tangent. Tangent is a line which cuts the axis, which cuts the curve at one particular point. And what I'll do, I'll take infinitesimally small position just beside infinitesimally small point. I'll take infinitesimally small point, that is x1 plus dx, with a small change in x. Similarly, with a small change in y. So here if you see, there is a triangle formed, and with the horizontal, if it is making an angle theta, at the triangle also the angle will be theta. And same story, sir, y2 minus y1, that is y1 plus dy minus y1, that is dy, and x2 minus x1, x1 plus dx minus x1, x2 minus x1, that is dx. So if I try to write slope at point P, it will be change in y, that is dy, upon change in x, that is dx, which is nothing but a derivative of y with respect to x, will give me instantaneous slope, and change in y by change in x will give me average slope. Okay, so theta is angle made by secant. A line which cuts a curve at two different points is called a secant. So theta is angle made by secant with x-axis in anti-clockwise direction. in anti-clockwise direction. What about the direction? I'll tell you in the next slide. So similarly, when it comes here, theta, here what is theta, sir? Theta is angle made by tangent. Tangent is a point where it cuts the curve at one particular position. So theta is angle made by tangent with whom, sir? With x-axis. In which direction? Anti-clockwise direction. Is that clear? So average slope is y2 minus y1 by x2 minus x1. Instantaneous slope is dy by dx. I hope it is clear, sir. Let us go to next concept. Now we will have example of the slope questions. Let us say we have a equation, a straight line is there, y is equal to 2x plus 5. There is a question, sir, y is equal to 2x plus 5. If I plot this on a graph, it will come like a straight line. Is that clear? Now, what is the slope of this particular point if they are asking? So, with the horizontal, we will take the angle theta, and for a straight line, at any position you take the angle theta, it will remain same. That means at origin, at x is equal to 5, at x is equal to 10, at x is equal to 20, any position you are taking the angle, we will get angle will be same. That means the slope of that particular line is same. So we will conclude one important point. For straight line, slope is constant. Okay, if it is a straight line, throughout the slope will be constant. And with the x-axis, I told you, anti-clockwise direction. We have to discuss in which direction, sir? Anti-clockwise direction. So we can also say theta here is acute angle. Theta is acute angle. So tan theta is going to be positive. So in this particular question, slope is constant and slope is positive. So we will try to keep that in mind, sir, that if it is a horizontal line, we have a question in this fashion, sir. It is a horizontal line. The graph y is equal to some constant. So we will try to take the angle it is making with the x-axis, and the angle here is how much, sir? 0. So slope is equal to tan theta, that is 0. Next, second example. We have a question in this fashion, and with the horizontal in anti-clockwise direction, theta you will take. So it is acute angle. So what we will conclude? Tan theta is positive. That means the slope is positive in this question. Coming to next example, we have a line like this. Now with the horizontal, I have to draw a horizontal, and in anti-clockwise direction, I will try to take the angle theta. In the anti-clockwise direction, I will take the angle theta, and if you observe carefully, theta here is obtuse angle. Theta here is what angle, sir? Obtuse angle. So tan theta in second quadrant, I hope you remember all silver tea cups. First quadrant all are positive, acute angle. Second quadrant obtuse angle 90 to 180. Only sign is positive, sir. Tan theta would be negative. So we need to remember this. If I am walking on a cycle, or whenever you are writing an exam, a pen is in your hand, you keep your pen on the graph. If it is like a horizontal line, so the slope is 0 for identification. Okay, and if it is like this, from the origin you are observing towards positive x-axis, and to walk on that particular line or to ride a bicycle, if it is very difficult to go, that means it is a positive slope. It is a positive slope. And if it is a straight line, constant and positive. Okay, now for example, you are riding a bicycle and the shape of the graph is like this. So what do you mean by that, sir? Negative slope. Okay, so this particular shortcut you have to remember, sir. Horizontal line, 0 slope, tan 0. If it is like this, theta is acute angle, tan theta positive, slope is positive. For walking it is becoming difficult, positive slope. For sliding it is becoming easy, negative slope. And if it is a straight line, constant. So here slope is positive and constant. Here slope is negative and constant. I hope it is clear, sir. Let us go to the next slide. Let us say we have a question in this fashion. We have a question in this fashion. They have given different points. Point 1, point 2, point 3. Okay. So at individual points, they want us to find the slopes. M1, M2, M3. So the options are like M1 greater than M2 greater than M3, M1 is equal to M2 is equal to M3, less than none of these. Like that, there are 4 options. Now you have to find instantaneous slopes at point 1, point 2, point 3 and bring a relation between the slopes at all the 3 points. This is the question. Okay. So what I will do, always a pen will be in your hand. You can put the pen as a tangent. That is the most easiest thing. Or else you draw a line, take angle theta. Draw a tangent with the horizontal, take angle theta 2. Draw a tangent with the angle horizontal, take an angle theta 3. So if you observe carefully, starting it was almost horizontal. Slowly as you go forward, the inclination is increasing. Inclination is increasing. Theta 2 is greater than theta 1 and theta 3 is greater than theta 2. And what is slope, sir? Slope is nothing but tan theta, not theta, tan theta. And as the angle increases, tan is an increasing function. Tan 0, 0, tan 31 by root 3, tan 45, 1, tan 60 root 3 by 2. It slowly increases. Correct? Tan 60 is root 3. So 0, 1 by root 3, then 1, then root 3 is 1.7 and so on. So it is an increasing function. More the angle, more will be the tan theta. So what we can write, therefore tan theta 1 will be less than theta 2 and theta 3 will be the highest. And what is tan theta? The slopes. So we can come to a conclusion that at position 3 the slope is highest. Understood? This is the theoretical understanding. But normally, practically in the basic English, if you have understood, you can see as the angle increases, slope is increasing. That's all. Directly by looking at the graph, you can say M3 is higher, M2 is lower, M1 is much lower. Okay. All right. We'll go to the next one. Now, maxima and minima is the topic that we are going to discuss. More about the graphs we will come back after we do area of the graph. Let us go with the maxima and minima now. So in a particular graph, in a particular function, if let us say the graph is something like this, it may be a sin theta curve or cos theta curve, something, the graph became like this. in this whole graph there is one specific point where the value of y is the highest and one specific point where the value of y is the lowest, and y is maximum at x1, y is minimum at x2, let us say, correct? Now in the process what I am trying to do, at both of these points I am curious to know how much slope is there, instantaneous slope. If I redraw the diagram over here, it will be like this, and for slope I need to draw a tangent, and with the horizontal the tangent is making 0 degrees. So slope at point A is tan 0, which is 0. Clear? Okay, leave it aside. Let us come back to point B. I'll draw the diagram of point B, and I'll draw a tangent here with the x-axis. What is the angle it is making? 0. So slope at point B would be how much? Again tan 0, which is 0. So we come to a conclusion that at both maxima point and minima point, instantaneous slope is 0. What do you mean by that? Who is instantaneous slope? Tan theta you can say, or you can also say dy by dx, which is nothing but derivative. At maxima and minima, the slope, because maxima point till that time it will increase, at that time it decreases, it changes its direction. So whenever the graph is changing its direction, the instantaneous slope is going to become 0, because if you draw a tangent it will be horizontal, and for horizontal line the slope is 0, right? Similarly at minima point, till the time it decreases, at minima point it starts to increase again. So if you draw a tangent, what will happen? The instantaneous slope is becoming 0. So we come to a conclusion, at both maxima as well as minima points slope is 0. Clear? Now what we will do with this information? Let us say they have given a function y is equal to 3x square plus 4x minus 5, right? And they are asking find where the graph is becoming maxima, where the graph is becoming minima. Like if I want to plot this in a graph, where the top peak is coming and where the bottom peak is coming, so they are going to ask us. So what we will do, we will take the help of this particular understanding. At both maxima and minima, its derivative is 0. So to find maxima or minima, what we will do, we will differentiate and equate to 0. At maxima slash minima points, slope, that is first derivative, is how much, sir? 0. So that is the step we are going to solve this question. So if you differentiate this particular question here, so 3x square, 3 is a constant, keep outside, derivative of x square is 2x, plus 4 is a constant, keep outside, derivative of x is 1, derivative of 5 is 0. Now after differentiating we have to equate to 0. Why? Because at maxima minima points derivative is 0 and we are going to find that. So 6x plus 4 is equal to 0. 6x is equal to minus 4. X is equal to minus 4 by 6, that is minus 2 by 3. So at this specific position in the graph at x is equal to minus 2 by 3, that is 0.6, either the graph is having maxima or the graph is having minima. If I substitute this value in this particular function, I'll get either the maxima point or the minima point. Is that clear? If I substitute this value in this equation, I'll get either maxima or minima, because at both the positions slope is 0, and we have one more step, that is step 2. To find whether it is a maxima point or minima point, whether you have maximum peak or you have minimum peak. So what we will do, sir, second derivative check we need to perform. We need to perform what, sir? Second derivative check. Now what is this second derivative check? We have to differentiate the equation again. We have to find f double dash of x. We have to find what, sir? F double dash of x. That means we have to differentiate this function again. This is first derivative, sir. Again we have to differentiate the function. So if you do differentiation again, that will become second derivative. Find second derivative, and if f double dash is greater than 0, what is first derivative? Slope of the graph. What is second derivative? The slope for the first derivative. Slope of slope, derivative of derivative, correct? So at maxima point, till the time it was increasing, and at that time it starts to decrease. So when you do slope of slope, the second derivative for maxima will be negative. That means less than 0. And if you go, either you will get the second derivative as a positive or you will get negative. Positive means greater than 0, negative means less than 0. And at maxima point, the derivative of derivative, that is second derivative, will be negative, that is less than 0. So you found, now we are doing reverse engineering. If I found second derivative less than 0, that means I will conclude it is a maxima point. Because I know at maxima the derivative of derivative will be negative. Now what I am doing, if I found second derivative negative, I will declare that at x1 the graph is maxima, and if it is greater than 0, then I will declare minima point, because at minima point, till the time it decreases, now it starts to increase at minima point. So the slope of slope, that is derivative of derivative, will be positive number, because it's keep increasing up beyond that point. So that means what, are greater than 0, correct? Now I'll come to conclusion. For any question, if you want to perform maxima minima, there are two steps to remember. What is step 1? Differentiate and equate to 0. If you do that, you will get the roots. Let us say you got x1 and x2, whatever the roots of the function are there, where the derivative is 0, you will get. Now in this x1 and x2, one is maxima, one is minima, correct? So what we will do to know which is maxima, which is minima, we will perform second derivative check. We will perform what, sir? Second derivative check. If second derivative is greater than 0, then minima point. Greater than 0, remember like this, greater than 0 minima point, less than 0 maxima point, like that. Because at maxima the derivative of derivative will be negative, that means less than 0 at maxima. So you have to remember it in simple terms. Step 1, differentiate equate to 0. Step 2, second derivative check. Second derivative greater than 0 minima, second derivative less than 0 maxima. Now if we do an example, you will understand it better. Let us go back to the previous example. What was the first derivative here? We got root as minus 2 by 3. And what is the first derivative? 6x plus 4. F dash of x is 6x plus 4. Now perform second derivative, sir. Differentiate it again. 6 outside, derivative of x is 1. Correct? So now second derivative less than 0 or greater than 0 we have got here, greater than 0. That means at x is equal to minus 2 by 3, y is, tell me sir, greater than 0, minima, and y minimum, what is the value of the y minimum is 3 into minus 2 by 3 whole square plus 4 into minus 2 by 3 minus 5. So when you substitute all these values, you will get the minima value. So in the graph, at x is equal to minus 2 by 3, it will be minima, and where it will be minima, so that value also we will get with the help of this process. Is that clear? Now again we will discuss one more example. Okay, please copy sir quickly. Next, step 1, step 2, differentiate and equal to 0, second derivative check. One more example. So let us discuss another example. Y is equal to, let us say, x cube by 3 plus x square by 2 minus 6x plus 5. Let us say they have given this question. Now they are asking find maxima and minima for this particular function. Find maxima point, minima point, maximum value, minimum value. That is a question. Okay. Now let us say, what is step 1 for solving the answer? Differentiate and equate to 0. Correct? So please differentiate, sir. dy by dx is equal to x cube. So 1 by 3 outside, 3x square. Next, again 1 by 2 outside, derivative of x square, multiply the power, subtract 1 from the power, that is 2x, minus 6 into 1 plus derivative of constant 0. So it will become x square plus x minus 6, and we have to equate it to be 0. That is our step 1. Correct? So now it is a quadratic equation, sir. So roots, what is the roots of a quadratic equation? Minus b plus or minus root over b square minus 4ac by 2a. Correct? So here a is 1, b is 1, c is minus 6. So on substituting, 4ac, 6 4 is 24 by 2a. So root 25 is 5 by 2. So there will be two roots when we will take plus and when we will take minus. So what is x1? Minus 1 minus 5, that is minus 6 by 2, which is minus 3, and minus 1 plus 5, so 5 minus 1, 4 by 2, which will be 2. So there are two roots. When I take plus there is a root, when I take minus there is a root. So what are the two roots? Minus 3 comma 2. So we will conclude at x is equal to minus 3 and at x is equal to x is equal to 2. Slopes are 0. So we can conclude that one point can be maxima, one point can be minima, or both can be maxima, both can be minima. But to know which is maxima, which is minima, what we will do, sir? Second derivative step. What we have to do, sir? Second derivative check. That is step 2. What is second derivative check? Find differentiation once again. So what is the first derivative? X square plus x minus 6. So differentiate again, sir. Derivative of x square. Okay, let me write here clearly, sir. So first I'll write first derivative. What is first derivative? I'll copy here, sir. F dash of x is x square plus x minus 6. This term I have wrote here there. Now I am going to do second derivative. So f double dash of x. What is the derivative of x square? 2x plus what is the derivative of x? 1. Now if second derivative is greater than 0 means minima, less than 0 maxima. So substitute at x1 f double dash of x1. How much is x1? 3. 2 into minus 3 plus 1, which is minus 6 plus 1 minus 5 less than 0. So minus 5 is a negative number, less than 0, sir. Therefore negative number less than 0 means what, sir? It is a maxima point. It is a maxima point. Y is maximum. And next x2, f double dash of x2. How much is x2? That is 2. So f double dash of x is 2x plus 1. So substitute 2 into 2 plus 1. So 4 plus 1, 5 is a positive number. So positive number is greater than 0. So it means it is a minima. At 2, y is minimum. Is that clear? So we have 2 points. One point we have maxima point and another point we have minima point. Is that clear? So this is how we solve. Differentiate equal to 0, we will get roots. If we do second derivative check, we will know which root is maxima, which root is minima, because both the roots slope is 0. So either of them will be maxima, either of them will be minima. Is that clear? Please copy, sir. We'll go to next slide. Right, next. Next concept we will go is area of a graph. So area of a graph is resembling with integration part. I hope you might have seen the lecture of integration as well. Okay. If not, pause it here and go learn integration and come back. So let us say they are asking us to find the area enclosed by this particular graph between x1 and x2. So this shaded region, they are asking us to find area. Is that clear? They are asking us to find the area of the shaded region. Now, how to find the area of this shaded region is interesting. Okay, we will assume a specific position at a position x, the value of the equation would be some y, and just beside that position we will have another position called x plus dx. And now if you observe carefully, this particular area was not a conventional rectangle or square or anything, but the shortest element that I have taken in vertical as well as horizontal, it is looking like a rectangle whose length is y and whose thickness is dx, because y x2 minus x1 if I do, the thickness would be how much, sir? Dx thickness. The area of the small element, if total area is A, then the shortest piece is called dA. We have discussed in the previous classes as well. So dA is the small area, and it is a rectangle, so length into width, length is given as y and width is given as dx. Okay, so y into dx is the area of the small rectangle. Now, like that, how many rectangles are there? So many rectangles are there. From x1 to x2, we have to join all of them. So joining is nothing but a integration, sir. So total area is nothing but integral dA, that is applying integral on both sides. And what would be the limits? From x1 to x2. And integral dx is x, like that integral dA would be A. So area enclosed is nothing but joining all the small pieces in the graph integral y dx. So I am coming here again to a small conclusion. Differentiation dy by dx is nothing but slope of a graph. Integration integral y dx is nothing but area of a graph. So differentiation corresponds with slope of a graph. Integration is similar to area of a graph. That is a very important point. You must keep it in mind. Next, one example we will see on this particular concept. Let us say they have given a parabola y is equal to 2x square, and they are asking us find the shaded region. What is the area of the shaded region? That is the question. So quickly, what we should remember, this is not a rectangle or sphere or a standard formula. This is a parabolic path. It looks like a parabolic path. So we can't measure by using multiplication division of this area. So instead we will go with what concepts are? Area enclosed is nothing but integration of the function. So using that logic, what we will do? We will say area enclosed is nothing but integral y dx. And what is the equation y in terms of x? 2x square. And they want us to find the area from the origin till x is equal to 3. So we will put lower limit as 0 and upper limit as 3. So constant into variables are, keep the constant outside. X square, that is x power n. So n plus 1 by n plus 1. and whenever there is limits, we call it as definite integration, and in definite integration there is no need to put plus c because anyway it is going to become 0. So directly the answer would be, so keep the constant outside. So first put upper limit minus lower limit, so that is x cube is remaining, sir. So upper limit 3 cube minus lower limit 0 cube, which is 0. So the answer would be 2 by 3 into 27. So 18 units. The area of this shaded region would be 18 units. Is that clear? I'll change the slide, sir. We'll go to next concept. So in this class, we have discussed about slope of a graph, average slope, instantaneous slope. If you take horizontal line, that is 0 slope. For walking or cycling, if it is difficult, positive slope. If it is sliding down, negative slope. These are the important points. Coming to next, maxima minima. At maxima point also slope is 0. At minima point also slope is 0. Then we will do second derivative check. Second derivative greater than 0 minima, less than 0 maxima. Area of a graph is nothing but integration. Area of a graph is nothing but integration. Slope of a graph is nothing but differentiation. Change in y by change in x. Now coming to different shape of graphs. Let us say straight line, parabola, hyperbola, circle and ellipse. So even though these are in mathematics, these are very lengthy in magnitude, as well as direct questions will come in mathematics, but in physics these are used in different questions, in a displacement question, velocity question, accelerated question, or force, momentum, gravitational field, potential. So coming forward in all the chapters, so we will have graphs, and in the graphs we will see these specific shapes. So what we should keep in mind, only the crux we are going to discuss today, and very very important. So straight line. In the graph we always have y-axis and x-axis, and if the power of y is 1 and power of x is 1, that means no square or no inversely related. If both the powers are 1, x power 1 as well as y power 1, then the graph will be a straight line, sir. What is the equation of straight line? Y is equal to mx plus c, where m is nothing but slope and c is nothing but intercept. C is nothing but what, sir? Intercept. Let me tell you. I have 3 lines. Line A, line B, line C. Line A, line B, line C. In all the 3 lines, you can see the slope is positive slope. Slope is what, sir? Positive slope. So what is the equation of line A? Line A equation would be slope is positive plus m, and intercept. Intercept is basically where you put x is equal to 0, y will be equal to c. That means it lie on the y-axis, where the graph cuts y-axis. Where the graph cuts y-axis, that is nothing but y-intercept, because at that position x value will become 0. At that position x value will become 0. Is it clear? So here intercept is positive, so plus c, y is equal to plus mx plus c for first line. Whereas second line, slope is positive, sir, because it is difficult to ride a bicycle on this. So positive slope, or you can also say in anti-clockwise direction theta is acute angle, so tan theta is positive. That is a theoretical answer. So it is m2 into x, and where it is cutting the y-axis at origin, so plus 0. So it will be y is equal to mx if it is passing through the origin. And what about the third graph, sir? What about the third graph? You can see the slope is positive. It is still acute angle, but where it is cutting the y-axis, in the negative side. In the negative side. So it is having a positive slope but negative intercept. So this is mx plus c, this is mx, and this is mx minus c. Right? Next, if you focus here on the left side, I will try to draw lines in such manner. Okay. Now again this is, let us say, P, Q, R. Line P. Line P is having negative slope because it is like sliding, or with the horizontal you take in anti-clockwise direction. It is an obtuse angle and tan theta is negative. So what is the equation of this line P? It will be minus m, and it is cutting the y-axis at first quadrant, that is plus c. So minus mx and plus c. And what about the line Q? Minus mx, and it is crossing the origin, so intercept is 0. And what about the third line? It is cutting the y-axis at negative intercept, so minus mx and minus c. So these are the line equations you should know. I hope you understood. Positive slope plus mx, negative slope minus mx, and it is cutting the axis at the first quadrant plus c, cutting the axis at the fourth quadrant or below axis, that will be minus c. Clear? So this much information on straight line is more than sufficient for physics. Got it? Next, parabola. So what is happening in parabola? If y power is 1, then x power should be 2, or if x power is 1, y power should be 2. Either x proportional to y square or y proportional to x square, then it will become a parabola. Shape will become a parabola. So parabola is basically like a cup shaped, U shaped. Okay, and the graph will turn towards the axis with power 1. Whose power would be 1? Like for example, if y power is 1 and x power is 2, the graph will turn towards positive y. And if x power is 1 and y power is 2, the graph will turn towards positive x. Like an example if I give you, so let us say they are saying y should be equal to 2x square. So what I will do, at x is equal to 0, y is 0. At x is equal to 1, y is 2. At x is equal to minus 1, minus 1 into minus 1 plus 1. So y will be still 2. Clear? And at x is equal to 2, y would be 2 square into 2, that is 8. And if you put x is equal to minus 2, still y would be plus 8. So at plus 1 and minus 1 you are getting the same value, that is 2. And at plus 2 and minus 2 you are getting the same value, that is 8. So if you plot all the points, it will be something in this fashion, and the graph will be turning towards the positive y-axis, because whose power is 1, the graph will be turning that side. Is that clear? Another example I'll give you. If x is equal to 3y square, x power is 1, y power is 2. Now for positive as well as negative values of y, x will be same. So the graph will be turning towards positive x-axis. The graph will be turning towards positive x-axis. Is that clear? Hello. So if both the powers are 1, then it is a straight line. Equation is mx plus c. If one power is 2 and another power is 1, then the shape would be parabola. The shape would be parabola, and whose power is 1, the graph will turn that side. If y is equal to minus 2x square, that means the value of y will be always negative. So the graph will turn towards minus y-axis. And if x is equal to minus 3y square, for any value of y, x would be negative. So the graph will turn towards this side, minus x-axis, like this. Is that clear? Okay. Next we will move forward. Hyperbola. Hyperbola is very simple, sir. Y and x should be inversely proportional to each other. If x power is 1, then y power should be minus 1, or if y power is 1, x power should be minus 1. And let us say at x is equal to 0, y will become 1 by 0, that is infinite, undefined. At x is equal to 1, y would be 1. At x is equal to 2, y would be half, 0.5. At x is equal to 3, y would be 1 by 3, 0.3. So if you see, for a very small change, you are coming from 0 to 1, the graph will come from infinity to 1. 0 to 1 x changed, infinity to 1 y changed. Then 1 to 2 you are going, it becomes 0.5. It becomes 0.5. Next you go 3, it will become 0.3, then 0.25. Then after so on, after a long time at x is equal to infinity, y will become 1 by infinity, that is 0. Clear? So this is the shape of hyperbola. This shape is called hyperbola. There will be a sudden steep decrease in the value. And in physics, where we will use, let us say, potential of a gravitation or a body is g m1 m2 divided by distance. So here potential is inversely proportional to radius. So the graph between potential and radius will be a hyperbola. So like that we will use this particular shape in different chapters, but it is mandatory for us to know that if they are directly proportional, the shape would be straight line. Y is proportional to x, straight line. If square is there, y is proportional to x square or x is proportional to y square, then it will be parabola. Then hyperbola. If there is inverse relation, the shape would be called hyperbola. Next, followed by circle and ellipse. So in circle and ellipse, both the powers, the equation of a circle is x square plus y square is equal to r square. And equation of an ellipse, in ellipse we have two focus, focus 1 and focus 2, and the horizontal diameter will be different, the vertical diameter will be different. So it is similar to circle only, but instead of one center there will be two focus, and instead of one diameter there will be two diameters. So the equation would be x square by a square plus y square by b square is equal to 1. If both the powers are 2 or squares and two constants are there, horizontal and vertical, two different constants are there, then the shape would be called ellipse. And only one constant is there. Anywhere you see the radius of the circle is only one. X square plus y square is equal to 8, or x square plus y square is equal to 12. Like that, any one constant is there, then it is called a circle. Okay. So both the variable power is 1, straight line. Any one's power is 2, parabola. If they are inversely proportional, hyperbola. Both the powers are 2 and one constant, circle. Both the powers are 2 and two constants, ellipse. So this we have to revise again, because in the exam when we write kinematics or gravitation or electrostatics, they will give a function. This physical quantity is related with that physical quantity. Which of the following options is right? And they will give one straight line, one ellipse, one hyperbola. So by seeing the function, we should be able to tell the shape of the graph. Then we will be awarded with 4 marks. Is that clear? So that's it for today, sir. Thank you all of you.